So probably, you might have heard about Flutter. Well, some people have heard about Flutter, and we like to say that it's a way to build fast, beautiful apps. And so if you are working on mobile apps, how many people see that and go, yeah, I've heard that millions of times before, right? Yeah, when I first started working on this, I told a lot of my friends about it, and they say, yeah, I hear about something like that every week. And they didn't, I have no time to waste on this. And so to them, saying something like this is like just using an old advertising slogan, right? We're just, nobody hears that. So that's the interesting thing about Flutter. It's actually very hard to promote in a way because there are anything we can say good about it, somebody else is already saying about a different one. So the reason I'm here today is to tell you why Flutter is different, okay? Because there are some fundamental things about Flutter that are very different than what has happened before. All right? So first I'm going to talk a little bit about, I'm going to divide up the field of mobile SDKs into 4 groups. And first, across the top, I'm going to divide them between ones that compile to native code and ones that are interpreted. And when they're interpreted, they're almost all using JavaScript, right? So I'll just assume that that's talking about JavaScript. And on the left, I'm going to talk about what kind of views they use. One is the traditional views, like model view controller. And then there's a newer one called reactive views. And I will talk about that quite a bit in this talk. All right, so, and the arrow sort of shows the way time's going. And originally, everything was native, and then it went to JavaScript. And React Native uses JavaScript, but it introduced reactive views. And now Flutter goes back to compiled to native, and it has reactive views. So it's the only system like this that is both compiled to native and has reactive views. So that alone is kind of interesting. So why do we care about compiling to native? And the problem is because something called the bridge. And so if your app is trying to talk to some of the phone services or get some events or talk to the widgets on your platform, then it has to go over what's called a bridge from the JavaScript realm to the native realm. So this is in a JavaScript app. And in order to do that, it has to do a context switch. And context switches are very, very slow, right? And you don't have to take my word for it. This is an article that somebody wrote about how to make apps, well, how to make React Native apps faster. And they're basically saying, don't, go across the bridge as infrequently as possible in order to get good performance. All right? So Flutter has reactive views. It doesn't need a JS bridge because it compiles to native code. And so that alone should be enough to make it interesting and worth trying. But that's actually not what this talk is about at all. I'm talking about the thing that's really amazing about Flutter, which is the widgets. Okay? So these are all screenshots from various Flutter applications. And Flutter takes a new approach to building widgets. In fact, we think of it as a new architecture for building widgets. And I don't think it's an overstatement to say that widgets are about the most important thing about mobile apps. A good mobile app will have really good widgets, and bad widgets can kill an app very easily. So let's look at why this is true. And with any luck, this will actually work.
So that's something as a start, where we took the WebView technology and said, well, WebView is constrained to have to render web pages, because that's what it does. And spent many years optimizing the web rendering engine in Chrome. And thought, well, what would happen if we took away the constraint of having to render web pages and just broke every compatibility thing we could imagine? And so we did a little experiment, and in a week we got some pretty significant performance gains. We thought, okay, maybe there's something here. And so then we took that experiment, and over several years, we finally eventually came Flutter.
So the key there, the key there is he talked about we wanted to break all the rules from previous systems. And the biggest change they made is the way layout is done. So layout is what controls where the widgets go on the page and how big they are and things like that. And so I'm going to first talk a little bit about traditional layout. And I'm going to pick on HTML and CSS, not because it's any better or worse than Android and iOS layout, but just because it's more familiar. How many people here know HTML and CSS? Right, almost everybody. All right, how many of you can tell by looking at this what the output of this will look like? Yeah, it takes a minute to think, doesn't it? It's not really obvious from looking at it what it's going to look like. Well, I'm going to go ahead and show you. It looks like that. Okay, so it's a column with two elements, or two widgets. It's a column of two widgets. The top one is the words hello world, and the bottom one is a green star. All right. So layout is interesting in that you have the layout rules and you have the widgets. The layout rules are global. They apply to all widgets. And so you have to merge those two things together. Now, the benefit of having that separation is called a separation of concerns, right? You separate the layout from the content. But it turns out that when you start doing things like mobile, and even worse, watches, that separation doesn't actually help you that much. And so we decided to get rid of it. Okay? So, hello? There we go. So, as I just said, there's problems with traditional layout. I mentioned that the rules are global, and so they apply to everything. So if you change one rule, you might change things you didn't expect. Another thing is that the rules have lots of different layout methods in them. They're all sort of thrown together into a big sink. And so there's the box model, which I actually was surprised. About a month ago, I found out that I always knew that CSS has two box models, one from the old days of Microsoft and one from the standards. But it actually has a third one, which I don't think anybody uses anymore, but it's still in there. Right, there's all this stuff in CSS. There's floats, tables. Flexbox and grid are interesting because they show that you can't just add new layout methods to CSS. It has to be built into the platform. And this was a problem that we saw. And so the biggest problem, though, is that CSS layout is very slow. And not only is it slow, but as you get more and more widgets, it gets even slower because it goes up with the square root of the number of widgets. And so building large, beautiful apps was actually very difficult in this. And the same things apply to Android and to iOS, of course. So what they discovered when they started playing with this is that most of the time when people are doing layout, especially on phones, it's very simple, right? They maybe have text on a scrolling page. That's like 80% of all layout is just laying out text that scrolls. And fixed rectangles on a screen that maybe vary their size when the screen size changes, that's like another 10%. So we've already covered a large percentage of layout right there. And then maybe there's some tables and floats and a few other things. All right. They also found that most layout is localized to a specific subtree of your widgets, right? So it doesn't really need to be global. You can actually just have layout that only applies to a small tree of widgets. And they use these facts to simplify and then optimize the layout engine to get a really fast layout engine. And so in order to do this, they invented a new architecture for layout. And because of this, they could not use the built-in widgets. So they could not use iOS or Android widgets, and they could not use WebView widgets, obviously. So Flutter does something very unusual. It includes all of its widgets with the framework. It does not use the native widgets, doesn't use WebView, it doesn't use anything like that. And not only that, but since they're part of your program, you can customize them. You can add new widgets, you can change existing widgets, you can do almost anything you want. And so this is one of the big goals of Flutter, was to be very customizable so that you could make exactly the application that you wanted, right? And the widgets are very simple, they're very fast, and as we'll see, I'll talk in a minute about the fact that in Flutter, everything is a widget, okay? So this is how Flutter does layout. So how many people can tell what this lays out? What does this look like? I hear voices, but it's exactly the same thing as before, exactly. All right, so it's pretty, and you've never even seen Flutter before, right? And do you know what language this is written in? This is written in Dart. Probably nobody in this room knows Dart, but now you do, right? You are all now qualified Dart programmers. So it's very simple to see this. You have a centering widget. How many people have done centering in CSS? How many times did you feel like pulling your hair out while you were doing it? Yeah, exactly. It's really hard to center something. In fact, in CSS, you have to tell your parent to center you. That's how you center something. And then there's like 8 different ways of doing it beyond that. Here, we just have one thing. You have a center widget, and it centers its child. And that's it. Right? And the same thing. We want a column. We want 2 things in it, some text, and we want an icon. And that icon has a property, which is its color. That's it. So I just want to show you some other widgets. You know, you just saw the centering widget. There's also padding and aligning. Until I saw this, it never occurred to me that padding, centering, and aligning are very similar to each other. They all arrange something in reference to its parent. And so we have these 3 things in Flutter. We also have multi-child ones. You already saw a column, that one. We also have a row. You can nest these, of course. You can have a row of columns or a column of rows. And so when you have these 2, you actually have everything that Flexbox gives you in CSX. All right, so it's very familiar. We also have one that CSS never had, which is stack. If you want to have a group of things and they are arranged from front to back, you actually put them in a stack so you can really tell. And that actually helps you when you're trying to figure out, like if you want to do a screen reader or something, we actually know that those things are laid on top of each other, whereas it'd be very hard to tell in CSS. And then I threw in this list view just because I already said that's about 80% of all layouts, so we have a special widget just for doing list views. Okay. And there's other ones. I didn't mention, we have a grid view, flow, table, wrap. And again, this is customizable. You can build your own layout widgets, and it's not hard. So if you want something that we don't already have, it's there. I mean, you can build it yourself. So I mentioned everything is a widget. We have a layout model that, as far as we know, has never been, you know, it's not in any other system, and it's called the Sliver layout model. And it's actually used to implement scrolling. And it means that you can implement not just simple scrolling, but you can have things scrolling around in all directions. And on that very first slide where I showed you all the different widgets, there was one where things were scrolling up while other things were scrolling sideways and moving diagonally and stuff like that. That's very easy to do. And so you can do unusual types of scrolling, anything you want. There's another one called the object layout model, which is a very general layout model. In fact, it's so general it doesn't even know about Cartesian coordinates. It doesn't know about X and Y. And that's already been used by people to do layouts in polar coordinates for a watch. So you can actually have a layout where you can tell it degrees or whatever you want, radians, and it lays them out that way. So it's very flexible. So that's not what the object layout model did. It was there, and you could customize it to be one for polar coordinates. And it was pretty simple. And that code is actually online if you want to play with it. Themes are treated as a widget. You can have a widget called theme, and you set a bunch of properties on it, and then the children below it use those properties. So you can change themes pretty easily. And if this theme doesn't work well enough for you, you can add your own theme, right? Navigation, so changing pages and things like that, that's a widget in Flutter. And your entire application is just a widget. All right. And I think I've said enough that you can create new kinds of widgets. Everybody gets that, right? So as a result, layout in Flutter is very fast. It's extremely fast. And in fact, it is so fast that we don't have any special code for scrolling. right? We have that sliver layout model. When we want to scroll something, we actually relay out the entire screen for that. That's how fast it is. And even if you have very complex layouts, it's linear most of the time. I mean, you can certainly write layouts if you try really hard that aren't linear. But so as the number of widgets grows, you can still use it, and it's fast. And it's simple to use. I mean, everybody here got what that layout did pretty simply. So, oh no. Did it go back? Well, I unplugged it, so. Almost. This part is the one part I don't think I can do without slides, so let's hope we get this back. Okay, so I'm going to talk more about reactive views. We started out by talking about how many people know, have used React Native or know how it works or anything like that. And you probably like it, right? I mean, it's actually really good. I like React Native. So reactive actually started in the web world. And it started with, there was a bunch of different systems. Probably the most well-known one is React.js. And in the web world, reactive introduced the concept of a virtual DOM, right? So in CSS and HTML, you have the DOM model, and this introduced a virtual DOM. And virtual DOM is immutable, which just means that you can't change it, which means that you have to rebuild it for every frame. So anytime something changes, you rebuild it from scratch. Okay, so let's look at how this works. So here's your app over here, and it's going to build a tree of widgets, or in HTML speak, they're elements. And then once you finish building that, you compare it to see how it differs from the real DOM, the one that's being displayed on your screen. And then you create a set of minimal changes. So you only change those things that need changing to get the new view. And those are sent here to the web view. They update it. And then after that happens, this DOM is rendered to your screen. Okay? And that sounds like an awful lot of work. You create a tree here, you update this tree, and then you have to render it. But it turns out that it's really fast because manipulating the DOM is very, very expensive. So if you can avoid doing that, that's great. So on the web, this was a really big win. And then what React Native did, it applied the same thing to mobile apps, which is really cool, actually, what they did. And so instead of this being virtual DOM, this is now a tree of virtual widgets. And after you build it, you compare it to the platform's idea of what the widgets are. You update only the ones that have changed, and then that gets rendered to a canvas. Okay, so it's very similar to the web technique. And this is a big win for native apps, because remember that this is the bridge right here. It's very expensive to cross that boundary between JavaScript and the native widgets. And so by doing this, you minimize the amount of communication you have for updating widgets. You're only sending things over for widgets that have changed. So that's really good. So Flutter, though, took this much further. What Flutter did is it said, what would happen if we just get rid of these OEM widgets? And remember, we already had to get rid of them because we wanted this new model of widgets. And so in Flutter, that is the widget tree. It's no longer a virtual tree. It's the only tree. That's where you put all your widgets. And the renderer is here in your app as well. And it does the same things as here. It checks to see only what has changed, and it only re-renders those things that have changed. And it gets the benefit of reactive views. And it renders directly to a canvas on your thing, on your phone. So only the parts that have changed get updated. And in fact, it uses a technique called structural repainting. using compositing. And it's a big term, but structural just means that it does it by widget. So on almost any graphic system, you keep track of what rectangles on your screen have changed, and you only redraw those because you don't want to have to redraw everything. This is faster because you can do it by widget rather than by rectangle on the screen, so you have a lot less to keep track of. And it uses bitblit for re-rendering things that haven't changed. And in fact, it uses them even for things that have moved, because you can still just bitblit those things. Bitblit is very fast, and that's why scrolling is so fast. We can actually just re-bitblit the entire screen if it's just scrolling up a little bit, right? So, I mentioned before that Flutter uses Dart language. There's reasons we use Dart. Actually, originally, Flutter was written in JavaScript when they first tried it out, when he was talking about the experiments. JavaScript didn't work very well for it, for a number of reasons, some of which I've discussed. So they actually they tried out a bunch of different languages. They actually, I've heard, went through 20 languages, and they ended up on Dart. And Dart helps a lot. One of the things it has generational garbage collection, and when you're doing reactive views, you're recreating that tree over and over again. If you have animation going on, that's like 60 times a second. So you're creating a lot of objects, and then you're just throwing them away. Generational garbage collection makes short-lived objects really, really fast. Also, allocation in Dart only needs to do a single pointer bump, so it's a very fast operation. And you can run garbage collection with no locks, so you don't have the slowdowns of garbage collection that other languages have. And it also has a tree-shaking compiler, which I'm going to skip talking about because we're slow. Anyway, more about Dart.
Yeah, so originally it was in JavaScript, and there was a very large DOM component that was implemented in C++, similar to how a web browser works. And as we were working on things, we realized that really wasn't all that necessary. Instead, you picked a language like Dart that you could compile down in native code. And you didn't need the C++ layer. You could lift all that mechanism in the browser is baked in and expose it to developers and make it much more powerful. So developers could reach in and subclass anything in the whole stack, all the way down from the widgets to the rendering layer, to the compositing layer. The whole stack is available for developers to customize and build beautiful fluid UIs out of it.
So the main point he's using there is he's talking about the fact that everything got moved into your app. The renderer is there. And so this is a diagram. Oh, not what I wanted to do. No. Hold on. This one's my fault. Sorry. All right, so everything on that diagram, which you can now see, is Flutter. And everything in green is written in Dart, and it's all exposed to you. So you can actually change or replace any part of that. So for example, if you wanted a new gesture in your application, like you wanted somebody to be able to do something like that to get rid of something, you could write that and add it to the gesture recognizer, something you could never do in other systems. The renderer is part of this, which is painting here under the renderer. The whole animation system is built in there. You can add new animations and so forth. The things that are not written in Dart are these underlying things. They use the text engine from Chrome because it's actually very hard to do a good text engine because you're doing all those weird scripts that go from right to left and from top to bottom and stuff like that. So that's built into it. And that would be hard for you to change, although it's still part of your application. And Skia is the 2D graphics engine used. And it also uses Vulkan for fast rendering on systems that have GPUs. All right, so compatibility. How many people have used compatibility libraries in Android? Right. How many people enjoyed the experience? Okay, nobody. Well, you can say goodbye to compatibility libraries. Because all the widgets are in your application, that means when somebody runs your application, even on an older phone, it doesn't matter. We don't care what the widgets are in the phone. Your application looks exactly the same, even on older phones. And that goes all the way back to Jelly Bean or iOS 8. Okay? And we could probably go back even further, but nobody seems to care to go back any further. There was a big change to how the graphics system worked in Android at Jelly Bean, which is why they stopped there. But if there was enough demand, they could do it. Another issue that sometimes people are concerned. Oh, I should mention. So one of the I saw 2 days ago, somebody showed me a Flutter app written all with material design, and it was running on a phone, running an operating system that was released 4 years before material design was even released. So that's pretty cool. You can actually make old phones look new. Maybe not run new, but you can make them look new. So anyway, updating widgets. So some people look at this and say, well, you're supplying all the widgets with Flutter. If Apple or Google come out with a new widget and I want to use that widget, don't I have to wait for you to add it to your system? No, you don't have to wait, because the widgets come with your application. If there's a new widget that you want, first of all, Google's likely to create a new widget to match it right away, especially with Android, because we also make Android, right? So we're going to upload those things as quickly as possible. But even if we completely screw up and don't give a new widget, there's other people who might want it. They can write that one, or you can write it. Again, all the widgets are built into the app. You know, they're part of the app. You can customize them, you can modify them, you can add new ones. And so there's no reason you ever have to wait for them. And then this, I only have one slide on this, but this is actually the thing that people like most about Flutter, and that's hot reload. So there were a couple people who said they knew about Flutter. Has anybody actually used Flutter? And did they actually get to use the hot reload facility? So when you're creating an app in Flutter, and you can see it happen here, you can go in and change the code, and then they're going to go up and hit this little button right here. That's the hot reload. So he's changing a word. He does a hot reload, and in 387 milliseconds, it updates the output. And so you can make changes. You can change colors. You can add widgets. You can make large changes. We've actually played around with it, changing large, and it's very fast. It's not the size of your app that counts for hot reload. It's the size of the code that's changed, because we only have to reload just the code fragment that's changed. And this really changes how people use Flutter. It means that you can just experiment. You can try something, see what it looks like. If you don't like it, you can back it off. You can just keep trying it. And the hot reload really works, and it's really fast. Okay. It comes with several widget sets. I'll mention a couple of them. There's a sort of a built-in widget set. I call it the Android set. It's not really Android. It's just like row and column and things like that. There's an iOS widget set, which is called Cupertino. There's a material design set. And we're now seeing some large companies start to build their own widget sets, because they want to have a certain brand for their applications. They want it to look a certain way. So you can build entire new widget sets. You can access native services, like the camera, the accelerometer, location services, and things like that. And we have these things called plugins. So you do have to write native code for those. But once you write that native code, you put it into our plugin library, and other people can use it. Or before you write that native code, look in the plugin library and see if somebody's already done it for you. And we only released the plugin library in May, and we already have, oh gosh, I don't even know. I haven't looked recently, but it's definitely over 100 plugins, and more are being added. There's now more plugins written by non-Google people than by Google people in there. And it's definitely an open source project. We have over 100 outside committers on it, and we encourage people to do that. So if somebody asks you what's new and exciting about Flutter, you now know what to say. You know, it uses reactive views, which are very popular. There's no JavaScript bridge. It compiles to AOT, which makes it fast. And actually, more important than fast for AOT compilation is it makes it very smooth. There's not really much jerkiness, because you're not going through a virtual machine. And in fact, it's better even on Android phones, because Android code written in either Java or Kotlin goes to JVM. And we go straight to the middle. We even compile down for graphical units. You can customize the widgets. You have full control over those widgets. I've shown you a little bit about the developer tools. I didn't show you the Flutter Doctor, which is very nice also. And it's a lot of fun to use these things. So this is the list of what's important about Flutter. What did I leave out from here? Can anybody guess? There's something I didn't say. It's like when I ask somebody what Flutter is, it's the first thing they say. They say it's a cross-platform development tool, right? And to me, that's not even important. I mean, you can write cross-platform. You can write one code base, and it will run on both Android and iOS. And it'll look like an Android app on Android, and it'll look like an iOS app on iOS. You know, they even got the scrolling behavior, which is different on two platforms, perfect. All right? But the reason it can do that is because the widgets are fully customizable. And the widgets themselves look and see if they need to do something like iOS or something like Android. And that means it can run on multiple. So it's customization that allows it to be on this. And that's what's important about Flutter, is that it's very customizable. It means you can do lots of different things. You can make it look like iOS if you want. You can make it look like Android. You can make it look like something entirely different if you want. It's up to you. How many people here have heard about a musical called Hamilton? Probably very few. Wow. So I've been running around Europe giving this talk for a while. And in some places, nobody's ever heard of it, because it's a musical about the American Revolutionary War, basically, which isn't very interesting unless you, you know, to most places. Anyway, this agency, Posse, wrote the app for it. It came out about a month ago now. There's already been over 1 million downloads of it. It was all written in Flutter. It runs on both iOS and Android, and it's very popular. I think in Android store right now it has a 4.8 star rating. So this was our first big success. There were lots of little apps being written for it, but this is the first 1 million download app that's been written for it. So one of the things I want to point out, though, is that Flutter is new. It's in alpha right now. There are things that are missing from it. It doesn't do internationalization as well as we'd like yet. There's other things that are missing. If you're interested in using Flutter, I highly recommend that you talk to us and see if it does everything you need. It probably does. Or if it doesn't, we might want to work with you to help us figure out the best way to do the things that's missing. And they actually really liked it. In fact, well, these are just some people talking about Flutter from various articles about material design. I'm going to skip through these fast. They like how fast it runs. In fact, it doesn't just run faster than cross-platform tools, it runs faster than Android itself. And this is my favorite one. This is from a guy who tried it, and he sent us an email saying that it made him so happy to use it. And I like that. And that's the end of the talk. I do want to point out a few of these things. There's actually a written article that is making the same points as this talk, and it goes into more depth. So if there's anything you were not sure of and need to have some questions about, that's a good place to look. Also, I just talked about Hamilton. The GDG that just happened a few weeks ago, there was a guy from the agency who wrote it. He was part of a presentation where he talked about their experience using Flutter, and that's a really good thing to watch. And that's the link. It's on YouTube. You can actually just search for Flutter and Hamilton, I think, and get it as well. We're having a conference in Los Angeles. Last year it was in Europe. This year it's in the US. I think next year it'll be back in Europe. And feel free to send me email and ask me questions, and I'll make sure you get to the right person. Again, it's a new product. One of the advantages of that is that all of the engineers on it are talking to people. We're talking to developers very strongly. which is sort of an unusual thing for Google. Usually our products are so large we can't talk to people. But right now, we keep very close relationship with people. And I don't know how long that will last, but for now, it's actually a big advantage. So thank you. And do you have questions? Yes?
Is there a roadmap for the beta for GA, the general availability?
So right now it is alpha. We are hoping, and I really mean hoping because we're not sure, that we go beta in time for Google I/O. We'll see if that actually happens or not, but that's our current goal. So if it doesn't happen then, hopefully it'll happen soon after that. One of the advantages of this project is that we're spending more time getting things right rather than doing them really quickly. And so we're more looking like to work with developers and have them tell us, okay, we need something that works just like this, and then we'll work with them to help them develop it. And because it's so customizable, often, people can do it themselves, but we'll work with people to help them add features that they need if they don't have. It's sort of an unusual alpha. Usually a product is called alpha because it's got a lot of bugs. And Google uses Flutter a lot internally. We use it for apps that control $70 billion worth of revenue for us. So it works, right? So the parts that work do work really well. It's mostly the pieces that are missing that we're working on right now. So, so don't yell at me if we don't make it by I/O. I think we will, but I'm not sure. Because if we can't do something right, we're going to delay it, and we're not going to call it beta until we think it's pretty much done. So, any other questions? Oh, that's somebody scratching their head. Nope. Well, thank you very. Oh, yes.
So you say that there were plugins for accessing, for example, the hardware device. That was.
Wait, say it again.
Yeah, you say that there were plugins to access hardware on devices, like sensors or. So, yeah. So what about other kind of services like push notifications?
For push notifications. I know that there's a couple of people working on that right now. I don't know what the progress of that right now. But if that's something you really want to do, I can get a real answer for you, but I'm not sure. I've actually been away for 3 weeks now. So.
And for example, for Google Maps?
That's a great question. And actually, I'm one of the people that really, really wants Google Maps, and we had a huge breakthrough just a couple of days ago. And so Google Maps is not currently supported in it. Well, you can put a map up, but it has to be full screen, because we can't put it inside of a widget. The problem is Google Maps draws directly to the screen, and we draw directly to the screen, and having two different things drawing to the screen at the same time is a problem, right? But they figured out a way to get around that. And the same problem applies to video, and they have video working. I just saw a demo of it 2 days ago, and it's really cool. It's not ready to release yet. They just barely got it working. Maps is exactly the same problem. So I've talked to them. I actually went and visited them. They're in Aarhus in Denmark. And as soon as they get the video working first, Maps is actually one of the most requested things that we get for it right now. And I'm one of the people screaming at them the most because I've done a lot of Maps and I would like to see Maps in it. So I'm hoping it will happen soon. I don't have a date yet. Before I couldn't even say that I thought we could solve the problem, because how do you deal with two things? And I'll even tell you what the solution was. What they did is we use OpenGL for rendering most of the time, right? And so rather than actually try to draw into something like that, we actually create a native canvas, and then we create a texture map and throw the video into that. And that's what then gets scrolled in, like if you want scrolling or you want, a smaller widget that you can change its size and things like that. So that was the big breakthrough, is figuring out that we could do it as an overlay in OpenGL rather than try to do it just having two different OpenGLs talking to the same thing. So, and it works. It works great. In fact, I don't have enough time. I'd show it to you if you want. If you find me tonight, I will show it to you working. So it's pretty awesome. Thanks for that question. That's a good question.
He also asked about accessing the hardware on the phone,
Uh-huh.
like the sensors and everything.
Right. No, you can just do that. That's what plugins are for. So the way you do that is the same way that any other library does it. It talks. What we have is it's called a platform channel. It just sends messages to the platform, and then you write native code on the platform to access the service. So what people usually do, like if you want to access the location, they would write a little bit of code to access that on iOS, and same thing on Android. And then you put those in what's called a plugin, and then when you compile your system, it uses the appropriate one. So if you're compiling it for Android, you get that. If you're compiling it for iOS, you get that code. And it puts it in automatically. It's actually really simple. So it's hardly any harder than just writing that native code in the first place. So the hard part is just accessing that. And for most services, it's pretty straightforward. So that's what's in the plugin library. So if there's something you need, just look in the plugin library and see if it's already supported. And if not, talk to us. Maybe we'll write one for you or help you write one. So, yeah, sorry, skipped your first question. Is that it? I'll be around today and tomorrow, so feel free to ask me any questions you want. Oh, I almost forgot. The most important thing. I have a pile of Flutter stickers. If anybody promises to put them on their laptop or somewhere else, you can have one. Actually, you can have one anyway. But all right, so these are the Flutter stickers. I don't know. I'll just leave them here, and people can grab. And feel free to grab 2 if you need to, or know somebody who wants one. So they're right here on the steps. And if that pile goes away, I have more where that came from. So anyway, thank you again.